After capturing and uploading the drone imagery, the fully autonomous processing pipeline turns the images into an exact digital representation of your asset, including all installed customer equipment. This digital twin can be used for a multitude of purposes, including overall inspection of the asset and equipment pre- and post-construction, auditing tower lease contracts for compliance, safety inspections or safety walks, lease and sales planning, third-party carrier review, and engineering analysis. In our platform, we focus on enabling three primary tasks: inspecting the tower and identifying what equipment is on it, capturing the measurements of the tower and equipment with sub-inch and sub-degree accuracy, and auditing the contracts on the tower to determine if that equipment is inside the tolerance of the lease terms or if the carriers are out of compliance. To achieve this level of accuracy, we use a fully autonomous processing pipeline that automatically optimizes the 3D model based on a known length of objects placed on the ground by the drone pilot. Using these objects, known as scale constraints, we can optimize the tower reconstruction and check the accuracy by looking at the accuracy score in the tool. We wanted to make the task of identifying the type of equipment from the office as easy as possible. To do this, we wanted to bring the 3D scene together with the drone imagery that was captured to give the user the ability to effectively walk the tower and inspect any area that was seen by the drone. Once we've identified the equipment, we enable the auditor to finalize the contract determination by quickly capturing the measurements of the equipment, including rad center, azimuth, down tilt, and elevation. Most of the time, it's as easy as 3 clicks to assign all of the measurements directly to the equipment. If there are situations where the equipment is at an initially difficult to capture angle or area of the point cloud, the user can use triangulation to use the drone imagery and fine-tune the positioning of the point. This adjusts all the measurements for the equipment automatically and ensures maximum accuracy for the equipment that was previously nearly impossible to capture. I can further tune this position by double-clicking onto the object to enter advanced resizing mode, which will adjust the height, width, depth measurement, and azimuth measurements for the equipment in real time. Seamless legacy enterprise database and catalog integrations allow our application to initialize the data on the tower to match what the team said was there the last time an audit was performed, as well as the current contracted lease terms to inform the user of what equipment should be on the tower and where on the tower it should be located. These contract terms can be viewed, and the associated equipment is nested underneath. If we don't find the equipment we're looking for in the existing list, equipment catalog integrations allow the auditor to search for the type of antenna by manufacturer, type, name, or physical dimensions to quickly add the equipment to the tower. When I've selected the equipment, I can quickly attach the volume I've drawn to it and automatically transfer the measurements to the equipment data. The auditor will continue until they identify, measure, and validate all equipment against the contract lease terms. Once completed, the auditor can check all the data back into the legacy enterprise database through the data connection layer, which can transform the data into whatever format is needed. Now the audit is completed and the data is available for use by upstream and downstream operation partners.